Welcome and thank you for joining for the 23rd Florida Keys Mosquito Control District Oxitec Public Educational Webinar. Our topic is a progress report on this year's project. The project is in its third year. We'll also speak a bit about mosquito-borne disease and the recent malaria cases in Florida. Our panelists are Andrea Leal, the Executive Director of the Florida Keys Mosquito Control District, Chad Huff, the Florida Keys Mosquito Control District's Public Education and Information Officer, Rajiv Vajanathan, the Director of U.S. Programs for Oxitec, and I'm Meredith Fensom, a Florida native and Oxitec's Head of Public Affairs. We're hosting this series of public educational webinars to share information with residents of the Florida Keys and provide forums to answer questions. These webinars are open to everyone. Webinars are recorded and made available for everyone after the event. All questions relating to the webinar topics will be answered. We may group similar questions together. And if time runs out, we will accept questions in writing via florida@oxitec.com. Our agenda is to give a little bit of background, then talk about this year's project design and the status to date. We will spend the second half of the hour-long webinar answering your questions. We will give priority to residents of the Florida Keys. If you are a Keys resident and you have a question, please include with the question the key that you live on, and we will answer those questions first. It's fine to go ahead and start entering your questions in the chat box now. Don't be shy. You will remain anonymous. Only the presenters will see who is asking the questions, and we will not identify you. Over to you, Andrea.
Thank you, Meredith. We like to kind of start these webinars talking about why the Florida Keys Mosquito Control District is interested in this technology. And it really all started about a decade ago when we had locally acquired dengue fever for the first time in the Florida Keys since the 1930s. And that has continued to be a challenge for all of us in South Florida since that time. We saw more locally acquired cases of dengue fever in 2020, and we've seen cases continuing, especially in the Miami-Dade area. I know this year, so far, they've had 5 locally acquired cases, and that means that their local mosquitoes are getting these diseases and then passing it on to the public. So, the threat of these diseases continues to increase. We saw Zika occurring in 2016, again in Miami-Dade. So it's really important that as mosquito control professionals, we continue to look for ways to control this particular mosquito. And all of those diseases are transmitted by the Aedes aegypti mosquito. Additionally, there's no cure or vaccine for the majority of those diseases that I just mentioned. On top of that, our control measures aren't working like they used to. We're seeing resistance developing and growing in a lot of the products that we use right now. And that just continues to spread throughout the state of Florida. And we also are really looking at using species-specific tools, right? So really looking at a method that can control Aedes aegypti specifically. It is our main disease vector here in the Florida Keys. And, if we can find tools that control just that, then we know that, we're moving in the right direction. And like I said, dengue really is our main driver as far as looking at Aedes aegypti control. Years ago, our main concern in the state of Florida were nuisance mosquitoes. And while those still are a concern for us, we've seen these mosquito-borne diseases on the rise. And it's really changed the way that we have done mosquito control since that time frame. So we're more focused on controlling these particular mosquitoes. And unfortunately, like I said, we are continuing to see introductions of this disease on a regular basis. So we're seeing folks that are traveling to other countries, bringing dengue back into the state of Florida, and then those local mosquitoes are picking up that disease and transmitting it. So it really emphasizes the importance of controlling those Aedes aegypti mosquitoes. And Aedes aegypti is an invasive species to Florida. As you can see from the map, it's pretty much moved all over the globe. And we first saw it in the New World and, around the 1600s, thought to come across with slave ships. And it really has continued to spread. And not only have we seen the spread of Aedes aegypti throughout the globe, but we've also seen the spread, here in the United States. We've seen its introduction into the state of California in recent years, and it continues to spread. So it really is a major species of concern for all of us because it is such a great disease transmitter. And I'll turn it over to Chad to talk a little bit about the malaria cases that I know are very interesting right now that are happening in Florida.
Yeah, thanks, Andrea. Yeah, interesting, kind of a new player to at least the recent history of mosquito-borne disease in Florida is malaria. Now, it's interesting in public information, we spend a lot of time talking about diseases named dengue, as Andrea mentioned, or there's some called chikungunya, and there's some called Zika, yellow fever, if you go back even further than that. But it's amazing. Recently, since 8 cases of locally acquired malaria have been found in the state of Florida, we've really been covered up with a lot of questions. The public has a lot of concerns when they hear the word malaria. That kind of it kicks it up a notch in the attention level. And I think that there's some reasons for that. It may be due to the fact we heard our parents talk about it, or I know in school, growing up, malaria was the one that was the disease that was talked a lot in the same breath with mosquitoes and with death and that sort of thing. So kind of our message to the folks that have asked about malaria in the state of Florida is to remind them a little bit of the geography. Thus far, these cases of malaria have been found in and around the Sarasota area, and that's several hundred miles away from the Florida Keys. And it's not unheard of. There are cases, locally acquired cases of malaria that are found. They haven't been found recently, or hasn't been a spate of them in one spot in Florida in some time, but it is not without precedent. One thing we talk about in the Florida Keys is the type of mosquito that vectors malaria is the Anopheles mosquito, and the particular type of Anopheles, while there are some that are found in the Florida Keys, it's not a predominant species that we see a lot of down here. So, that being said, we spent some time talking about this mosquito-borne illness, but we also remind folks that the precautions that they take for all mosquito-borne illnesses. The nice thing about them is they protect you from all mosquito-borne illnesses. So, you wear your repellent and that sort of thing. But one thing is for sure, it just hammers home that the district is on the right track here about being concerned about mosquito-borne disease, regardless of what type of disease it is.
Thanks, Chad. So the relevance here for what we're doing, this is an update for the Oxitec project in the Florida Keys for 2023. As Andrea mentioned, we're here to assess our technology against an invasive species called Aedes aegypti. And as Chad alluded to, the vectors of human malaria are Anopheles mosquitoes, and so mosquitoes from a different genus than Aedes. Our technology currently that is in use in Brazil and that we have been evaluating in Florida for 2.5 years now is against the invasive Aedes aegypti mosquito. And here you have a picture of a male Aedes aegypti in the center. Basically, what we have is an approach where our male Aedes aegypti mate with the local invasive Aedes aegypti. There's nothing sterile about it, so that insemination leads to fertilization. And so the target female then lays fertile eggs. Those eggs hatch. Female Aedes aegypti lay their eggs in temporary water in natural and artificial sites. Her eggs then hatch. Both male and female larvae hatch. However, because of the self-limiting gene expression in female larvae, all female larvae carrying a copy of that gene die as larvae, and only male Aedes aegypti emerge. So they complete their larval development, they pupate, and they emerge as adult Aedes aegypti males. Now, you may not know this, but only female mosquitoes bite. Only female mosquitoes have the proboscis to actually penetrate skin and to imbibe blood. Female mosquitoes feed on blood to develop their ovaries and to lay eggs. Males cannot bite. They don't have the mouth parts for it. They don't have the components of saliva. They can't even digest blood. And so this technique focuses on killing the larvae of females, whereas the males survive, and then they continue the cycle. They emerge as adults. They go off and they mate with other females. Because it's Aedes aegypti, because this is a technology on one species, it is highly targeted. And so any concerns that people might have about, oh, you're reducing mosquito populations, and yet mosquitoes play an important role in ecology. Absolutely, mosquitoes play an important role in ecology. Aedes taeniorhynchus, for example, the salt marsh mosquito, is a very important source of food for aquatic predators like frogs and fish, and the adults can be important for dragonflies. However, Aedes aegypti, because it is, one, a non-native invasive species, and two, is found really scattered about in low population density, is not an important source of nutrition for aquatic predators or for aerial predators. And so when we say targeted suppression, we're attacking one particular species out of 3,500 species of mosquitoes. And this one is a non-native invasive species, which is an important vector of multiple viruses. In addition, because this is a self-limiting gene technology, it is non-toxic to any other organisms. And so there is a role for pesticides in mosquito control. You can ask any mosquito control district. But pesticides cost money, and pesticides can have unintended effect on other organisms. And so an advantage of using a genetic approach to controlling an invasive pest mosquito is that it is non-toxic and non-allergenic and targeted for this one species. Moreover, we have found that it effectively kills female larvae, which is very exciting. And we have 3 lines of evidence indicating that any female that carries this self-limiting gene dies as a larva. We have collected, as we release, we also collect. And so of the tens of thousands of fluorescent larvae that we have collected, every single one emerges as an adult male. Not a single has emerged as an adult female. And so it's not 99% effective. It's not 99.9% effective. Every female that carries this self-limiting gene dies as a larva. And I mentioned that it's a male-only release and that male mosquitoes do not bite. And moreover, it is traceable in the field. I alluded to fluorescence. So this self-limiting gene, which kills female larvae, also has a fluorescent gene. And so when we collect larvae, and we'll talk about that in a minute, when we collect larvae, one, we want to count the total number of larvae that we have. And then 2, we put a special fluorescent filter in the microscope, just as you would a UV polarized sunglasses that filter out harmful UV rays. We put in a red filter into the mosquito. And then our larvae, that is those which have been sired by our males, will shine like a Christmas tree. We can tell which larvae carry the self-limiting gene because that self-limiting gene is also connected to a fluorescent gene. So they're traceable in the field. We know where they are. We know how far they distribute. And keep in mind, with every generation, the males aren't going to mate with every female, right? So you get fewer and fewer and fewer until finally we no longer detect the gene in nature. We monitor for that after we stop a project and we are no longer releasing any males. We continue to collect larvae and we continue to collect adults looking for fluorescence or the self-limiting gene. And we find that the gene persists for a few months or a few generations, but there is an attrition from generation to generation to generation until finally our gene is no longer present in the population. That was a lot. So I'll get to what we've done this year. I love this pic. Our project design this year really focuses on 2 important questions. One is, how do they work in a neighborhood? And 2, how do they work at an individual household level? Those are our 2 big questions. To answer both of those questions, there's some overlap, but there are also some very unique and distinct projects for what we call the B, or the neighborhood projects, or the D, the single home projects. So the elements involve the single point releases, where we're trapping males and we're collecting larvae. We also have multi-point releases, neighborhood-wide, again, collecting males and whatever comes after that. So collecting larvae in natural and artificial sites, including little cups that we put out. We replicate everything we're doing and compare them to untreated sites or control sites. And those locations we could not have done without you. There is no one's property and there is no one's backyard that we are going into unless they've agreed, unless they've signed on to it with full disclosure of what we're doing, either releasing males or releasing males and trying to collect. So setting up those black plastic cups or setting up little light traps which enable us to collect mosquitoes. So we have trap hosts and we have box hosts, and sometimes those 2 are the same function. We could not do that without the overwhelming and widespread support of the community in the Florida Keys. As we mentioned, we trap adults and larvae, so this gives us different kinds of information. Trapping adults lets us know what the baseline population of Aedes aegypti is, and trapping larvae gives us an idea about distribution, and also, since we're collecting all the larvae and we're looking for fluorescence, it gives us an idea about the mating fraction, or what percentage of larvae are the product of our males mating with the local invasive female Aedes aegypti. We also make sure that everything we do is within neighborhoods and not near sewage treatment plants or citrus orchards where females might go and lay their eggs. What are we really evaluating? So those are some of the metrics, right? That's the project design. But what are we really evaluating? Well, we want to know the number of male mosquitoes released, because this is a product. At the end of the day, people like Andrea and other directors of mosquito control districts would use this as a tool, a very targeted tool against Aedes aegypti. Andrea has a budget and she has time, limited time, and she has limited staffing. So she needs to know, okay, I know how much of a pesticide I spray, when and for how long and how much it costs if I want to hit all of these areas. She needs to ask the same question about our product. How many are we releasing? How does that translate into how many you need in a neighborhood? And what is the effective reduction in a population given different rates of release? Critically, and this is probably the most important thing we can come out of this, is what is the percentage kill of the female larvae? And I can jump to the punchline right now and say that the percentage kill is 100%. So every female larva that we have collected in the last 2.5 years that carries that fluorescence dies as a larva. And when we collect in an area where we've released our males, and so it's also kind of giving us an idea about what our sex ratio is, but it's also telling us what the percentage is that live and then emerge as adult males. When we look at adults, every single adult that carries that fluorescent gene is a male. And so we're getting different lines of evidence indicating that the presence of the self-limiting gene kills female larvae, and we are not seeing any female adults that carry the self-limiting gene. That's probably the most important thing I can say. What proportion of the invasive population are we actually getting successful mating with? We also kind of discovered last year that when our males mate with local females, yes, we can collect eggs in our little black cups, but we wanted to make sure we didn't have trap bias. So we also collected larvae from other natural and artificial breeding sites, from discarded coconut husks and bromeliads to ditches and gutters. And my favorite last year, kayaks and jet skis. So female Aedes aegypti are opportunistic. They will lay their eggs in natural and artificial temporary water sites. And we found that when the mated females disperse, yes, they certainly lay eggs in the cups that we have in which we collect them, but also in other sites. So that is a very useful tool for dispersal. One of the challenges in controlling Aedes aegypti is that both larvae and adults are cryptic or hidden. You cannot treat that which you cannot see. And of course, the females also seek harborage in vegetation where it is difficult to spray an adulticide. Very often they are active during the day, and because of pesticide regulations, you really cannot spray when Aedes aegypti are most active and when they are biting. This is a challenge for mosquito control districts. And finally, we wanted to look at the duration of effect. In other words, when we release our adult males and we keep releasing them for so long, how long is it effective in killing female larvae, and when do we not see anything anymore? There we go. This is a schematic of our Project B and our Project D. Project B is neighborhood wide. And so we're looking at a complete neighborhood, and we talk to just about everyone there, and we ask, do we have your permission to trap? So that's just setting up these light traps to collect adult mosquitoes, or setting up black plastic cups with a tongue depressor in it to collect eggs, or releasing our male mosquitoes from our boxes. So our objectives for Project B, for the entire neighborhood, are really to understand full suppression. Can we use this as a tool to control Aedes aegypti neighborhood-wide? And if so, what does that mean? Do we need to put 1 per acre, 1 per hectare? What is our rate of actual release? And so Project B is very much a neighborhood-wide project, and that is of particular interest for mosquito-controlled districts. Project D, on the other hand, is one home. So there might be 20 houses around, but we're really only releasing at one site, at one home, and we have overdone the number of traps around that person's home because we really want to answer a different question there, and that is not dispersal. It's not how far they fly. It's not how much coverage can we get. The one question for Project D is, are we seeing fluorescent larvae in and around that person's home? And are those fluorescent larvae males emerging as adults? And are all the female fluorescent larvae dying as larvae? So there are two very different objectives between a neighborhood-wide and an individual home. It's also to the point of operational deployment. Project B is really what a mosquito control district would be interested in, to really control it on a wide area, whereas Project D is very much at a household or a single consumer level. Our goal is certainly to have this a product that homeowners can use for their property. So it should be something that they can access and essentially put mosquito control in the hands of an individual homeowner. The aims of our programs, regardless from B or D, are to show the strong performance of our males. And that means, are they emerging? How many are emerging? What do the boxes look like? Are we sure that they're mating with local females? And all of that is to supplement existing data from 2021 and 2022 on how far our boys fly. In fact, last year we had one more project where we took adult male Oxitec Aedes aegypti and we dusted them with powder, with yellow, and then the next week with blue, and then the next week with pink, and we released them. And we collected them to see how far they fly and how long they live. And we'll get to those results in a second. So we have to look at dispersal, longevity, and how well our males mate with local females. And all of these data are relevant to support product registration. By product registration, we hope to have a commercialized product that both mosquito control districts and the individual homeowner can use for very targeted Aedes aegypti control in the US. Project B, the neighborhood-wide releases, started in April of this year on Vaca Key. We have Project B treatment sites and what we call control sites, so untreated sites, both on Vaca. So we can really make an apples to apples comparison. The Project B, or house-specific or homeowner-specific treatment, started 1 month later. It really was a question of logistics. We could not start everything at the same time. For our purposes, we really needed to stagger it in terms of our personnel and in terms of timing. So that explains why we started Project B in April, Project D about a month later, also on Vaca. And we have Project D control or untreated sites, no boxes, no releases on Vaca also, but also on Key Colony Beach. By the way, we have two kinds of boxes, and we're replicating our pros. So this is similar to what we had last year. But this year, we also have something called the mini box. Since the mini box is smaller, it releases fewer male mosquitoes. It is intended for homeowner use because it is easier to handle and it is a little more discreet. And so someone can put it in the back porch, under the areca palm, in an area where they essentially control mosquito control in their own backyard. So some of our volunteers this year are hosting the new mini box. It's a Just Add Water box, just like the Pro. So there's no change there. The box itself has a plastic liner inside with eggs and a little bit of food. You add water, shut it. The mini is a little smaller, but both the mini and the Pro essentially do the same thing. The eggs hatch once you add water. The larvae develop, male and female larvae. However, the female larvae die before they pupate. So if you remember from high school biology, a butterfly has an egg, a caterpillar, a pupa, and an adult. Well, mosquitoes do also. And so the eggs hatch, the larvae develop, the male larvae live, the female larvae die, the male larvae then pupate, and then the adult males emerge. So it doesn't matter if it's a Pro box, which is the usual size, or if it's a mini box, which is a little smaller and is meant for homeowner use. The idea is to just add water, shut it, and then the larvae develop, and the male Aedes aegypti exit out of those little slots that you see. So our status now, we're coming up on time, so I want to be respectful. First of all, again, I want to reiterate, none of this would have been possible were it not, first of all, for FKMCD for hosting us, for just being supportive, for working with Meredith on communication and outreach. It is only because of 10 years of public outreach and town halls and webinars that we have the support we have. So none of this would have been possible without our FKMCD partners. And that only goes so far unless the public supports you. I have knocked on thousands and thousands and thousands of doors in the Florida Keys. The majority of people have been supportive, they've been helpful, they've been enthusiastic. And think of it this way, we could not have done this scope of Project B and Project D in 2023 had it not been for success in 2022. And everything we did last year was predicated on our pilot projects in 2021. People have been eager to sign up. So none of this would have been possible were it not for our FKMCD partners and the residents of the Florida Keys. So for Project B, the area-wide, which we did last year, and we are replicating this year. As I mentioned, we started in April. We expect to go as late as October. We've found that our males fly typically about 50 to 100 meters, some of them a little more, but all of this is within range for Aedes aegypti males in the literature. So I guess I don't have any news for the dispersal. Essentially, the most boring thing I can say is that our males fly just like normal, otherwise Aedes aegypti males that you would find. What that means is that they mate with other females within their orbit. And so we found that our Oxitec males live long enough to effectively find and mate with the invasive Aedes aegypti females. So when it comes to how far our males fly and how long our males live, they are no different than the local Aedes aegypti male. There's nothing super about them. I know I've said this before, but I'm excited, and I think it really matters. 100% of female offspring that carry the self-limiting gene, and we identify that through fluorescence, as we see in this slide, 100% of them die. When you try to raise them, all the females die. When we collect from those release boxes, we collect only males out of the tens of thousands that we've collected. Every single one is male. And when we collect separately away from the boxes, when we set up what's called a BG or a biogens trap, which is really selective for Aedes aegypti. And when we identify adult male and female Aedes aegypti, everything that is an Oxitec Aedes aegypti is male. And so with 3 separate lines of evidence, larvae, and then release boxes, and then kind of an agnostic trap that just collects all the Aedes aegypti, we found that every single fluorescent larva emerges as an adult male, and that this has been an effective female-specific larvicide against this invasive species. We are detecting reductions in the local Aedes aegypti populations. That changes. It goes up and down, admittedly. Some of that is a function of weather. Some of that is a function of the dispersal of our males. And some of that is also a function of the periodicity of when our males come out. And so it is, as you would expect, spiky. 1 week will have a lot more male Oxitec Aedes aegypti, so we have a higher male to female sex ratio, but that dies out until there's another rain, until there's flooding, and then you get another one. So that's choppy, all true. But it does result in a reduction in the local Aedes aegypti population, which is exactly what we were looking for Project B, the neighborhood-wide release. Finally, for Project B, we're really excited to find fluorescent larvae in natural and in artificial breeding sites. So what that means is that our males are mating with local invasive Aedes aegypti females, and those females, their oviposition or egg-laying behavior has not altered. They continue to lay their eggs in a jet ski or a coconut husk or the clay saucer at the base of a pot. And admittedly, these are cryptic sites. They are difficult to target with traditional mosquito control technologies. So we're really excited about that. Project D is the single home project. So here we really want to make sure that every single fluorescent larva emerges as an adult male, not as an adult female. And I'm very happy to say that that is true. Like I mentioned, we staggered Project D from Project B. So we started a month later. And so far, fingers crossed, no tropical cyclones, no Ian, no Fred, no Elsa. So far, our projects this year have been uninterrupted. The mini boxes are producing males efficiently. So that's a big relief. We're glad to say that we have a product that is smaller, more convenient, more discreet, something that homeowners can actually use in their backyards. So we know that the adult males are being released. We know that not a single female is being released. We know that they are flying about 50 to 100 meters, just like any other Aedes aegypti male, and that they are mating with Aedes aegypti females. And the most critical result from Project D is that the mating results in male and female larvae. All the female larvae from one of our males, from a female mated from one of our males, die as larvae, meaning that their brothers continue their larval development and pupation. They emerge as adult males, and then they go off and they mate with other females. But it's not perfect. You don't get 100% mating. Every female does not mate with one of our males. So there'll always be a sliver there of survival. So once we stop, which would be in October, September for Project B, October for Project D, once we stop, we continue monitoring. And we continue monitoring for eggs, and we continue monitoring for adults. So then we can answer the question, what is the persistence of the self-limiting gene in the population? And we've done the same in 2021 and in 2022. And we find that, yes, indeed, it persists for a couple months, and it then, because it's a self-limiting gene, it then disappears from the population. And I will hand it back to Meredith.
Thanks very much, Rajiv. We'll turn to our questions now. And for those of you in the audience, if there's something you're curious about and you haven't asked a question yet, please do. We want to hear from you. We want to make sure we're answering the most relevant things. You can just put your question in the chat box and you will remain anonymous. Okay. The first question we have is, and Andrea and Chad, we'll ask you two to take this one. The question is, how come malaria is showing up in Florida all of the sudden?
Well, I think it's similar to what we see with other mosquito-borne diseases. So as long as we have those vectors, which we do in the state of Florida, there's always going to be that chance that someone has traveled to a country where malaria is prevalent and then comes home and gets bit by mosquitoes. So I think it's really kind of the perfect storm. The Sarasota area has enough of those Anopheles vectors that have bitten someone that had traveled and then are feeding on the local population of folks there. And we saw the same thing when dengue came back to the United States. Like I said earlier, we hadn't seen dengue since the 1930s. And then all of a sudden in 2009, we saw, almost 100 cases in Key West. So I think as long as we have these vectors, which we do in most areas, we're going to continue seeing these diseases pop up.
Thanks, Andrea. The next question can also go to you and is somewhat related. The question is the hot weather causing more mosquito problems?
So I would say that as far as more problems, probably not more, but we are seeing mosquito development increasing. Means they're going through their larval stages much faster. So a lot of what we do here at the district is a larvicide. So we're applying a product to the water. Those mosquitoes will ingest it and it kills those mosquito larvae. Normally, we have a good 3 to 4 days to be able to find those mosquitoes, treat them, and see an effect. While now that the weather has increased with heat, it goes a lot faster. We really only have about a day or two to find them to where they're feeding and they are ingesting that larvicide. The other thing that we take into consideration is we are seeing warmer temperatures in areas that we haven't seen them before. So potentially we could see the spread of these vectors, moving to areas where temperature could have had an effect on them before. So I do think we're going to continue to see the ranges of these mosquitoes expanding as long as we're seeing this heat lasting in areas we haven't seen before. So that's definitely something that we're all keeping an eye on.
Great. Thanks very much, Andrea. The next question, really any of you could answer this. The question is, malaria can kill you, right? Does it always kill people? Rajiv, Andrea, Chad, I think anyone who wants to take this one, please go for it.
Well, no, I can jump in on that. So malaria is a very serious disease. It is found throughout the tropical and subtropical world. And there are different kinds of parasites. There are 4 main parasites that cause malaria. However, it is not always fatal. So the majority of people who are actually infected with the malaria parasite will get sick, and they may even be incapacitated and may spend a very long time in the hospital. And that can be devastating for their family because they cannot work, and they can't really provide. So it has a lot of other effects on a community, even without killing. The most fatal kind of malaria is called cerebral malaria or falciparum malaria, and that is particularly devastating for children, so children under the age of 5, children under the age of 10. So the short answer to that is malaria can be fatal, yes. However, the majority of cases are not, and fatality is typically associated with age, with young children, with immunocompromised individuals, and it could also be among the elderly or with people who are severely malnourished or undernourished. The other thing to consider here in Florida is that the species of parasite that was isolated from the cases in Sarasota is not known to be a fatal strain of the parasite. And so one may still have really severe fever and chills, and a cyclic nature of that fever and chills. And it can be really devastating and tiring, but it may not be fatal. So that is a unique case here in Florida. I can defer to Andrea.
No, I really don't have any more to add. I think, Rajiv, you covered that very thoroughly.
Okay, thanks, Andrea. Thank you both. Rajiv, this next question will go to you too. The question is, will all the data collected over these 3 years be submitted to the EPA? And for those of you watching, the EPA is the Environmental Protection Agency, and they are our federal regulator in the United States.
That's right. Everything we do has to be approved by the EPA. And then there's a second layer in Florida called the Florida Department of Agriculture and Consumer Services, or FDACS. So we have to comply with all of those regulations regarding experimental design, who gets to review those data, who gets to inspect as well. So our team has been inspected by FDACS from the time we develop our boxes to deployment, to ensure that there is fidelity in our chain of custody. And so all these data from 21, 22, and this year, we have to collate and submit as a single dossier to the EPA. In addition, we have been providing reports to the EPA. Essentially, as anyone who knows, with a big project, you need to satisfy short-term milestones before you can really wrap it up into a nice deliverable at the end. So yes, we have been sharing all of this with the EPA, and at the end of the day, our goal is to submit it for what's called Section 3 commercialization. And so everything from Florida will be submitted to the EPA and simultaneously to FDACS to ensure that anything we're doing has that federal regulatory oversight. The other, what I'd put probably a small asterisk next to that, is that it is to our benefit to submit a manuscript for a peer-reviewed publication, so that anyone in the scientific community would be able to read it, know exactly what we did, understand the experimental design, and poke holes in it, essentially, and argue or challenge it. But it has to be available publicly to ensure transparency in experimental design and reporting of the results.
Thanks, Rajiv. This next question will go to you also. The question is, what were the results of the first trial in 2021? Are those results public?
Those results are not public because we haven't submitted the full dossier to the EPA. However, the results of the first trial were kind of baby steps. We wanted to see how far were they flying, how well were they mating, and what was the death of female larvae. So those three numbers we have presented in conferences for the American Mosquito Control Association. We've presented them at the Florida Mosquito Control Association, FMCA. We've presented them in New Jersey and in Wyoming, and multiple times at the Mosquito and Vector Control Association of California, or MVCAC. And so essentially what you saw today, talking about experimental design and then breaking that down to be as quantitative as we can and share that in public. Yes, we've presented that at professional meetings. We have not put those numbers out on a website. However, we also cannot do that until we have submitted a final dossier to the EPA and to FDACS. So the results of the first trial in 2021 really set us up for 2022. We know that our males fly about 50 to 100 meters, and some of them a little bit more than that, but still in line with Aedes aegypti. We know that our males mate with local females. We know that local females do lay eggs in our cups and in other artificial and natural breeding sites. And we know, most importantly, that every female larva that has the self-limiting gene dies as a larva. And we have presented all of those data publicly at national conferences and at departmental seminars at UF Gainesville and other universities. But we have not put that out as a newsletter because we need to make that as a formal report before we are even allowed to share that with the public.
Thanks, Rajiv. The other thing to add for everyone watching, during our 2021 project, which was the first year, and then also last year, we've done mid-project updates like we're doing today, and then also end of the year. And all of those recorded webinars and the slides are available on the project website, keysmosquitoproject.com. So a lot of good information there. And there'll be more coming with our regulators and eventually a publication. The next question, Andrea, will go to you. The question is, how concerned are FKMCD that malaria will become an issue down here?
So luckily, we really don't see high numbers of the vector for malaria in the Florida Keys. So it's something that we're keeping an eye on, but not really concerned with. The other good thing is, all the products that we use currently for controlling our salt marsh mosquito also are effective against the Anopheles mosquito. So, we are continuing to treat areas where we would find these Anopheles mosquitoes, but that's why we do such a good job with surveillance. We have over 100 traps that we set on a weekly basis throughout the Florida Keys. And with that, we really know what different mosquito species that we have. So that's how we know that we don't have, high numbers of the malaria vector here. It's actually very rare for us to collect malaria vector in the Florida Keys. But again, it's something that we're keeping a close eye on, and we'll know as soon as that changes. So that is definitely a good thing.
Great. Thank you, Andrea. We've had a few questions come in kind of late, but we are going to try to get through all of them. We have 3 more questions. And the next one, Rajiv, if you could take, the question is, will Oxitec be working to stop malaria mosquitoes?
Oh, how cool. Yes, I'm sorry it's not in Florida. We have two projects, one in Djibouti in the Horn of Africa and one in Panama. And those are for two very different Anopheles vectors. The one in Djibouti is against an Asian species, an invasive Asian Anopheles mosquito called Anopheles stephensii, one of two principal vectors of malaria in urban sites in Asia, and now horrifically is found in Ethiopia and in the Horn of Africa. So we are developing the same self-limiting gene technology against Anopheles stephensii in Africa and against a mosquito called Anopheles albuminus, which is one of the most important vectors of human malaria in Latin America.
Great. Thank you, Rajiv. The next question could really go to any of you. The question is, I remember we used to raise money for nets overseas. What medicine did they give to soldiers in Vietnam for malaria?
Well, at that time, it was probably a chloroquine derivative. So the best news I can say is in the last 30 to 40 years, we have new drugs. We have mefloquine, we have artemisinin, we have at least 4 to 5 new molecules that have been developed against malaria in the last few decades. Even those are exhibiting some resistance now. But during the Vietnam War, it was probably a chloroquine derivative. And if you were to try any chloroquine derivative against a malaria parasite from Southeast Asia today, they would swim in it and be just fine. There is so much chloroquine resistance in Plasmodium parasites.
Okay, thanks, Rajiv. The last question, which could also go to any of you, and I know Chad, you're dealing with this a bit. The question is, how do we get the public to fully embrace this technology when conspiracy theories are rampant about Bill Gates sponsored science experiments? How do we address this when talking with Floridians? But this can go to any or all of you. There's probably lots of opinions.
I think a lot of people already know the answer to this, and that is, first of all, we tell people don't believe everything you read, right? And especially with the internet, not everything on the internet is true. And I think a lot of people know that. But what's interesting about this year, and what I think is very interesting about this particular urban legend, was the media really jumped in really quick. And I'm talking about the mainstream media, the rank and file media, the people that we kind of rely on, the Associated Press, Reuters, Google, some of these other ones jumped in really quick and launched their own fact check, urban myth buster within hours of that appearing. And I think that's really encouraging. And it says something to me about how preposterous that really was. So I tell people that this one was kind of self-checking. A lot of people bought into that right away and poked a pin in it.
Thanks, Chad.
And I'd add that as the question is worded, right, how do we get them to fully embrace this technology? And the answer is you won't. We're on the other end of a global pandemic, and we still have people who hold out against something as innocuous as wearing a mask or getting a vaccination. And so you will always have some percentage of people who believe in conspiracy theories. But the most hopeful, the most optimistic and encouraging bit of data is that people will do the right thing when it affects their family. And talking to Keys residents, some of whom were skeptical, and they had heard, oh my gosh, you're releasing these mosquitoes here, and what is it going to do to the ecology? What is it going to do? They had some really outlandish ideas. I put my clipboard and my pen down, stood in front of them, and I said, listen, I'm the director of US programs at Oxitec. What do you want to know? And it really is that disarmed one-to-one conversation to say, I hear you, and to lean into that discomfort and to understand where they're coming from. And you know what? 10% of them are just going to reject it no matter what. But it's really those who are on the margin or who've heard it from a friend, or I read this on Facebook, those are the ones who you can really talk to and say, what are your concerns? Let me answer them. So it's the best thing out of all of this is the very widespread support that we've seen in Florida and in California. And when people do have questions and we have an opportunity to, again, put your clipboard and pen down, show your hands and say, ask me anything. And we talk through it and we talk about, the rationality of what we're doing. People get it.
Yeah, agreed. And I think the most important thing that we found is that as long as we're open and transparent, answer questions. I mean, this webinar is a great example. This is our 23rd webinar, and we welcome the public to join, ask any question that they want to, and we'll answer them. So I think it's important that we continue to be as transparent as we can about the project and what we're doing and what we're finding.
Thanks very much. And for those of you in the audience looking for more information about this project, we've set up a dedicated project website. It's jointly hosted by Florida Keys Mosquito Control District and Oxitec. It's keysmosquitoproject.com. And it's just about this project. There's a lot of information there. But if you do have questions that come up, you can also write to us at florida@oxitec.com, and we'll be more than happy to answer your questions. We appreciate everybody's interest. A recording of this webinar will be made available after the event, and hope to see you for the next one. Thank you all.